In this section of the course, we will have a deep treatment of gears. So gears are of course fundamental elements in any mechanical design. So let us understand the fundamental concept of gearing, which is called as the principle of gearing or conjugate action. So let us consider two cams. A cam is basically a part which transfers motion by contact. So there are two cams over here. One is the driving cam in the green color and it rotates at an angular velocity of omega 1 for a specific instant. And that cam is transferring the rotational motion to another cam, the orange color cam, with an angular velocity of omega 2. So driving cam is the green color cam and the orange color cam is the driven cam. Now at a point C, the green color cam will contact the orange color cam and transfer a force which is along the line of action AB. So there will be a force which will be generated at the point of contact C, which will have a line of action AB. So for both the cams, the linear velocity at that instant for the point C on the green cam as well as on the orange cam. So the point C, the point of contact, exists on both the cams. One is on the green cam and one is on the orange cam. So the point C, which is coincident for both, has the same linear velocity along the direction of the line of action, which is AB. So the velocity is in the direction of the red arrow. That linear velocity is the same for both the cams. And that is proportional to the radius of the two cams and their angular velocities. So if you are connecting a point between the two centers, between the two rotating centers, and we are finding the intersection point between the line of action and the connecting center to center line, this is called as the pitch point. Now if you are drawing two arcs, one arc which is having the center as the center of the green cam and with the radius R1, which is basically OP, radius R1, and another arc which is having a center at O for the second cam, that is orange cam, and the radius OP again over here, which is R2. So these two arcs have a tangent which is a common tangent which is called as the line of action, which is the same as the line of action. And these two arcs are having the radius R1 and R2, and that linear velocity, the linear velocity of the point C for both the cams is equal to the multiplication between R1 into omega 1, and that is equal to R2 into omega 2. So linear velocity of point C, V is equal to R1 omega 1, which is equal to R2 omega 2. So this common linear velocity will give us the equation which is giving the relation between the radii as well as the angular velocities, as R1 omega 1 is equal to R2 omega 2. Very important point to note over here is that the nature of contact at C is rolling contact. So when the rotation happens, the green cam rolls with respect to the orange cam. And that rolling happens because at the point of contact, the curvatures of the two cams are having a common tangent. So that is the reason why rolling will happen. And because of that rolling, a common velocity will be created, and that velocity is related by the equations R1 omega 1 and R2 omega 2. And from that we can relate the motion of the driven cam to the driving cam. Because if we know R1, if we know omega 1, if we know R2, we can find omega 2. So we are considering two cams, one is driving and other is driven. So the driving cam rotates at instantaneous angular velocity omega 1 and contacts the other cam, which is the orange cam, at point C and impinges a force along the line of action AB as shown. So there will be a linear velocity component along the line of action and will be the same component for both the cams. It will be the same for both the cams. The velocity is as a result of the force which is being exerted. So the force is causing the rotation of the driven cam with the angular velocity omega 2. So the force is along the line of action. Now if we are drawing a line from center to center of the two cams, and if we are making it intersect with the line of action AB, we get a point P, which is called as the pitch point. Now with OP as radius for R1 and R2, we create an arc with the radius R1 and R2 and write the linear velocity function as a function of radius and angular velocity, which is over here R1 omega 1, R2 omega 2. So the angular velocity of the driven cam will be higher than cam 1 in the same ratio as per the pitch radii. So as the pitch radii, the radius R2, if it decreases, the angular velocity will increase. So R1 omega 1 and R2 omega 2 will remain constant, which is linear velocity v. If R2 reduces, omega 2 increases. If R2 increases, omega 2 reduces. So the angular velocity of the two cams is inversely proportional to the individual distances of OP or radius. And the hash line indicates the tangent to the curves at contact. So this hash line indicates the tangent of the curves of the cams at contact point C. So for continuous motion throughout the rotation, there should be a rolling contact at point C always. So the motion is dependent on the nature of the curves which are in contact. So the nature of curves of the orange cam as well as the green cam at the point C will decide whether there will be a rolling contact across the range of motion. This property of having rolling contact and a uniform velocity ratio across the range of motion is called as the conjugate action. So when this cam rotates, when the green cam rotates, this point, the point of contact between the green and the orange cam might change, and this tangent which is tangent to the curves at contact might be changing, and hence this will change the line of action AB, and the angle of the line of action AB with respect to the horizontal will keep on changing through the rotation of the cam. So this variation of the linear velocity and the velocity ratio is not suitable for any application because we would want a uniform velocity ratio. Now if we want a uniform velocity ratio, the profiles which are contacting each other should be designed in such a way that they are always having that rolling contact. So they are always having a constant line of action which is having a certain angle with respect to the horizontal, and this tangent always remains constant and having the same orientation with respect to the references. So that property of having constant rolling motion as well as the uniform velocity ratio is called as the conjugate action. Now that is achieved by the nature of teeth which are contacting each other. So one way of doing that is using the involute profile teeth. So that is the reason why involute profile teeth are used in gears, because they give conjugate action at the contact and they give the rolling motion between the teeth. So using the involute profiles, we get a constant line of action and pitch circle diameters. Hence, we get the constant velocity ratio. And that is the motive of gears. The gears are used to reduce the speed or increase the speed, or to reduce the torque or increase the torque, which is having a constant ratio. So if we are replacing the cams with gears and mating teeth which are having conjugate action in between them, then we are performing the same motion. Only thing is that we are maintaining the uniform velocity ratio throughout the rotation. Now consider that those two cams have been replaced by two gears which are mating each other, which are having constant rolling motion in between their teeth which are under contact. And this is the pitch point. This indicates the pitch point, and this is the pressure line, also called as the line of action. So this is the line of action. This line of action will be constant for the complete rotation of the two gears. And R1 and R2 is given by the distance between the pitch point and the two centers. So R1 is the pitch point to the center of the driving gear, which is generally called as the pinion gear, and pitch point to the center of the second gear, which is a driven gear, which is generally called as the gear, is R2. So R1 omega 1 is the velocity along the line of action, which is called as the linear velocity. R2 omega 2 is the same, and from that we can get the velocity ratio. So R1 by R2 is equal to omega 2 by omega 1, which is the velocity ratio between the two gears.